Hi, this is Mrs. Sharp. We're going to quickly talk about what should be 0.4 here, which is given lab data, determine the percent yield of a chemical reaction and explain why the percent yield of many chemical reactions is very low. Today we're just going to focus on this first part, determining percent yield, and we'll talk about this part later. Let's talk about what the goal of percent yield is. Percent yield tells us how much of a product you can actually expect to make given the true nature of the reaction. Okay, so it tells us how much of a product you can actually expect to make given the true nature of the reaction. So there may be some things about the reaction that cause it so that you can't make as much product as we've been calculating you should be able to get. So some reactions have like a characteristic percent yield that will tell us, okay, in the real world, how much of this am I actually going to get? So it's very relevant to the real world. Okay, we need to talk about two things here. Theoretical yield versus actual yield. So the theoretical yield is the number of moles, grams, or liters of a product that should be made during a reaction, and that is figured through a stoichiometric calculation. So this would be exactly like some of the problems we've been doing at like a mass. So like your quiz today. How many grams of something should I make if I start with this many grams? So theoretically, I should make this many grams. Now the actual yield is what is actually produced. Okay? Usually less than the theoretical yield due to the nature of the reaction for some reason. Now, obviously, the goal of any industry sort of chemical reaction would be 100% yield. So you would get exactly what you intended to get theoretically, but it just isn't very common for reactions to do that for a lot of reasons. So let's talk about what percent yield actually is defined by. So the formula for percent yield is just your actual divided by your theoretical times 100. So your actual yield divided by your theoretical yield times 100. It sort of looks like the percent error calculation, so be careful. It is related, but it's not the same. Remember, percent error tells you how far you are off. Percent yield is telling you how much you made of what you should have. Okay, so there's your percent yield. Real easy calculation there. Steps to follow. The first thing that you want to do is find your theoretical yield. So that's the very first thing you want to know, and you already know how to do this. It's a stoichiometric calculation. So it's either a mass or a mass volume or a volume or a mole mass or something that you already know how to do with the master plan. And then you simply follow the formula using the actual yield given. So it'll be given to you in the problem, and you just plug it in and find your theoretical yield. Easy. So here you go. Let's try one. Sample problem. 14 grams of aluminum hydroxide is present in antacids to neutralize stomach acid in a double replacement reaction. Okay, time out. Let's write this equation. Aluminum hydroxide, Al is +3. Hydroxide is -1. So there's my aluminum hydroxide, 14 grams. And it reacts with stomach acid, which is hydrochloric acid. It's giving me the formula. And in a double replacement, I would get water, HOH, and aluminum chloride, which would be AlCl3. And to balance that sucker, we're going to need a 3 here and a 3 here. So step 1 is to find the number of grams of, well, it tells us 20 grams of aluminum chloride is formed. So this right here is your actual yield. So since they're using aluminum chloride for my actual yield, aluminum chloride is formed, we're going to find the number of grams of aluminum chloride that should theoretically be formed. So theoretically, if I have 14.0 grams of aluminum hydroxide, we're going to go through the stoichiometry, and that's a mass problem. I want to know how many grams of aluminum chloride I should theoretically make from this mass of aluminum hydroxide. So my first step here is going to be, if you're looking at your master plan, remember, I'm over here with grams, my first step is going to be to use the molar mass of my unknown, which is, let's see, 17.01 times 3 plus aluminum, 26.98. So I'm getting 78.01 grams of aluminum hydroxide for every 1 mole of aluminum hydroxide. Awesome. Grams of aluminum hydroxide cancel. Now I'm here, I'm going to use the mole ratio. So for every 1 mole of aluminum hydroxide, I'm going to make 1 mole of aluminum chloride. So moles of aluminum hydroxide cancel. And for every 1 mole of aluminum chloride, I'm going to have, let's see, 35.45 times 3 plus my 26.98. 133.33 grams of aluminum chloride. So I'm getting that theoretically 14 divided by 78.01 and then mole ratio is 1:1, so times 133.33. I'm getting that theoretically we should make 23.9 grams, theoretically. So my percent yield, if I made 20, I've got 20 grams divided by 23.9 grams, multiply by 100, and you're going to get 0.8, 20 divided by 23.9 times 100. This is taking me longer than it should. It's late. It is 83, not 0.8. That would be without multiplying it by 100. 83.7% yield. So that's a pretty doggone good percent yield. Now be really careful. Some problems, like the ones I'm giving you today, some problems like those will give you not excess HCl. So if they were to say not excess HCl, but they're to say 20 grams of HCl first, be careful. You might have to find the limiting reactant first. So you might have to go through, and if this was the case, you'd have to find the number of grams of AlCl3 that should be made from 20 grams of HCl. So you'd start this whole thing, 20 grams of HCl, blah, 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 get a number, and it would be something number of grams of AlCl3. And you'd have to do that same thing from the 20 grams of aluminum chloride. Oops, I'm sorry. From the 14 grams of aluminum hydroxide. I misspoke there, sorry. So in other words, instead of saying in our problem that I have a certain amount of this and excess HCl, that automatically tells me if I have excess HCl, that aluminum hydroxide is my limiting reactant, and I go with this mass. But if I have two masses, 14.0 grams and 20.0 grams, I first have to find which one of those is the limiting reactant so I can get the correct theoretical. So I'm going to say to find correct theoretical. Because if you don't find a limiting reactant and you just use whichever one of these you want, you might not be picking the one that actually makes the theoretical yield. So you got to find your limiting reactant. Now in this problem we didn't have to do that because of this word excess. So if you see excess as a reactant, you're good. If you see two masses or 2 moles or 2 liters for your reactants, then you're going to need to go through that limiting reactant step. So watch out for that. I know that is in your practice problems. In fact, I want to show you exactly where. So let me open this up for you. And we want practice problems. Okay, so check out today's practice problems that you have. All right. 1 and 2 are just basic limiting reactant and how much is left over, because I feel like some of you still need to work on that. 3 is, you got to watch out for this right here. 100 grams of each reactant was used. So the first thing I ask you to do is to find the limiting reactant in excess. Once you do that, that's going to tell you your theoretical value. So it's whichever one of these is smaller. Number 4 is the same thing. Number 5, I need for you to make a correction in number 5. So right now, while you're thinking of it, in number 5 it says if 20 grams of copper are used, let's say in excess silver nitrate. So that one you don't have to do a limiting reactant problem. Okay, so go ahead and do that for me, please. So we just added in excess silver nitrate. And number 6, we need to do the same thing as well. So let's say with excess carbon. Okay, so just add with excess carbon to letter A. And add with excess AS2O3 for this guy down here. Okay, so if you see excess like that, you don't need to do a limiting reactant problem. You can just go with the mass they give you to find your theoretical yield. Same thing here. And here is your actual yield, right? And here is your actual yield. Okay, same here. This is your actual yield. So use this value to find your theoretical yield because you've got excess of your other reactant. Now these two, I walk you through that step of doing it so you don't have to worry about it. Okay, so there you go. I've talked at you long enough. Now it is time for you to try some of these practice problems. They are due on Monday. We'll pick up on your lab Monday. Best of luck. Have an awesome weekend.